My presentation of chemistry that changed the world is on nanotubes. What are nanotubes? Carbon nanotubes, CNTs, are allotropes of carbon that have a cylindrical nanostructure with a diameter of less than 1 nanometer. Each carbon is bonded to another 3, all of which are sp2 bonds. Electrical conductivity. CNTs can be metallic or semiconductors along their tubular axis. This is due to their special geometry. In theory, nanotubes can carry an electric current density of up to 4 × 10⁹ amps per centimeter squared. This is much greater than any metals such as copper. However, in practice, junctions between nanotubes and impurities in the nanotubes themselves have lowered the conductivity. Strength and hardness. CNTs are the strongest materials man has invented in relation to their tensile strength, as well as the toughest in relation to the elastic modulus. This is due to the carbon-to-carbon sp2 bonding. CNTs are harder than diamond, which have carbon-carbon sp3 bonding, with the bulk modulus of some CNTs being 462 to 546 gigapascals. However, due to them being hollow when under compression or under bending stress, they are likely to buckle. Thermal conductivity. Carbon nanotubes are also very good thermal conductors. They have a property called ballistic conduction, which allows them to conduct about 3,500 watts per meter per Kelvin. How have they changed the world? Discovery. Nanotubes were considered to be invented by Simio Ligema when he released his paper on CNTs in 1991. Although CNTs were actually discovered before this, Simio's paper brought CNTs to the attention of the scientific community. Current uses. CNTs are currently being used in the composite materials with plastics to improve the properties of the plastic. CNTs are currently used in the production of many sports equipment, such as bicycles and skis. Amroy Euroboy has made wind turbines and a variety of sports equipment 20 to 30% stronger due to bonding CNTs with epoxy. Also, in tissue engineering, CNTs are being used as a support frame for bone growth. Possible changes nanotubes could make. CNTs could be spun into fibers and then into yarns, which would allow it to form a wire-like roll. CNT yarns could replace copper as a winding material. A company have already made a motor with them. They also have the ability to be used to control nanoscale structures due to their flexibility and strength, as well as the ability to be hollow, allowing them to contain other nanoscale structures. That's CNTs.